recording. Okay, so just to refresh where we get our booklet from that we are working through. So remember, it is when you go to contents, you look for the 2011 measurement and moles, and you download either the DocX booklet if you want to just type in directly, or the PDF booklet if you want to prefer to print and handwrite. The PDF booklet also, it means it doesn't matter what system you've got, everything will transfer properly. So in other words, you won't lose images or anything like that. Just a note, please do not work through the modules. I mean, you're welcome to have a look at them, but the calculations in chemistry and also for the titration standard is done all through the booklet. And you only go into the modules when you are ready for the teacher marked assignment. So this is what the booklet looks like. And you'll see at certain points in the booklet, they will tell you to answer questions as you go through. And when you finish this bit over here, you upload, complete your final questions and upload to the Dropbox. So you would have to go into the module in the last lesson to find this teacher marked assignment. Now, again, you don't have to do all this right now. If you're busy with another module, you know, you're just here listening, and you can do this work when it's in your planner or when you are planning to do it. Right, so what we've done, and I have done YouTube links for this, we looked at the first few things already, and we were busy on counting the amount in mole, and I really want to work now on the calculating mass and molar mass. So there are also little videos in here. So having the electronic copy is great because you can just go directly to that. Now, any questions so far? You're welcome to put them in the chat. That's a little speech bubble. Okay, now, what you do need to know, and I'm just going to go over this again because it's really important, is you need to know what these symbols mean. What does a big M mean, a capital M? What does a little n mean? What does a small m mean? You need to know units. So for example, when I have G MOL to the -1, or what am I talking about? What quantity am I talking about? If I have a unit of G, what am I talking about? So make sure you learn that. So I'll go very, very quickly through this. So the quantities you need to know are the amount, and that has a symbol of N and a unit of mole and abbreviation of mole. You just drop the last E. Then you have mass, which has a symbol of small m and the unit of gram. Now note this is different to physics. Physics, the unit is kilogram for mass. For chemistry, it's gram, just because atoms are so tiny. So it's already, you know, we're trying to make the unit a bit smaller. And the symbol for the unit is G. And then the last one is molar mass, which is the mass of 1 mole of substance. Now remember, mole was how we count. So instead of saying a dozen eggs, where we mean 12, we say like a mole of eggs. Well, there'll never be enough eggs in the world to have a mole of eggs, but it's this weird number of 6 times 10 to the 23. I'm really abbreviating that. You really don't use this number again, so don't worry about that. But it's a capital M, and the unit is a gram per mole, and the unit is GMOL -1. Because once you know those, you'll find the calculations a lot simpler. So if I go through this booklet, you can also use your units to see whether you have the equation correct. So the way I imagine the equation is I can have n is equal to small m over big M. That's the way it is given in the assessment task and the exam. So you are given the formula. So don't worry too much about that because you can look it up. But when you want to what we call change the subject of the formula, so instead of asking you to calculate amount, I'm asking you to calculate mass. So one way of doing it is using the units, or just simply saying, okay, I want M on this side, which means I need to get rid of the big M. So how do I get rid of the big M? I have to multiply both sides. Now this is sort of straight maths. Big M, and these will cancel out because M over M is equal to 1. So that will cancel out. And therefore, mass is equal to the amount times the molar mass. So make sure you can manipulate these equations. It's basic algebra, but don't let the word algebra scare you, because all you have to do, if you really want to, is you can also use the triangle. You may have seen these triangles before, where you have n over here, small m over big M. And so if I want to calculate n, you can see it's small m over big M. If I want to calculate m, then you can see it's just n times m. Or if I wanted to calculate, let me get this off, whoops. If I wanted to calculate the molar mass of something, given the mass and the amount, okay, it's unlikely you'll ever do that. It's normally that you have to get the molar mass from the periodic table. But if you wanted to, then you just say, okay, it's going to be small m over n. So you can use the triangle method. The only thing with the triangle method is you've got to remember the triangle. And if you put the wrong things in the triangle, you're going to get stuck. But if you find that easier, use that method. Okay, right, so let's practice. Now, the first thing, as I said before, this formula of n, n is equal to small m over big M, always is for one substance. So if I'm talking about sodium sulfate, it's the amount of sodium sulfate in this mass of sodium sulfate divided by the molar mass of sodium sulfate. Okay. And right. So that's the first thing you've got to know. So that's why when I've done this booklet, I have put these in just to make you aware that you've got to have the same thing in all of these. If you've got something different, so say they've asked you what mass of sodium is there in sodium sulfate, I can't have mass of sodium when all my other values link to sodium sulfate. So that's the first thing you've got to be aware of. Everything has to relate to the same thing. Okay, so I'm just going to do the first one, and then I want to push on to the others that are slightly more difficult. So here we've got just simply, we had n is equal to small m over big M. So now to get m by itself, I have to just make sure your big M looks different to the small m. I have to take the big M to this side, so it's n times big M, and so it's the amount. That's why I said you've got to know your units, because when you see mole there, then you know that this is amount and it links to n. So our amount is 0.825, okay, multiplied by, and you go, oh, I don't know big M. What am I going to do? Remember, in the assessment task, we will always give you the molar mass and also in the exams. But because you're practicing in the workbook, I make you calculate the molar mass. So you have to go to the periodic table at the end of this module. So if I just go to control end, okay, there is something over here at the very end. So you will need sulfur is 32.1, oxygen, sorry for the sideways, 16.0, and sodium all the way over here is 23. So if I go back, sorry, it's going to be the long way around. And now I'm going to go down again. So I have to do this calculation over here, where I have got 2 sodiums, so 2 times 23.0 plus 1 sulfur, which was 32.1, plus 4 oxygens, which was 16.0. And if you do that calculation, you should, can anybody beat me to it? 46 plus 32.1 plus 64 is equal to 142.1. Now, it's also a good idea not to just have a mess of numbers, because if you go wrong in your calculation somewhere, say in the exam or in the assessment task for the titration standard, if the teacher just sees masses of numbers, you know, you just put all masses, if you just put the numbers everywhere, then it's difficult to know how you were thinking. So always say what you are calculating and then give the unit. Your answer must have a final unit in order to get excellence. So we just say 142.1 grams per mole. You don't really need units in here, but you can if you, and then if I just do that, multiplied by 0.825, I get 117.2325. Okay, and my unit for mass has to be gram. Now, I'm not going to get excellence for this answer because I gave all the figures in my calculator. So remember last week we spoke about significant figures. Significant figures are important because they tell you how accurate your measurements were and therefore how accurate your result is. So if I've only measured to 3 significant figures, I can't quote an answer that is a lot more accurate or a lot more precise than the measurements I was given in the first place. So you always give your total number of significant figures as the least number of your given values. So this was given to 3 significant figures, 825, you ignore the first 0, and this was given to 4 significant figures. Even though in the calculation they were all 3 significant figures. So really, but because the smallest precision was 3 significant figures, your final answer has to be 3. So what would my final answer be? What would you give as the final answer? Does anybody want to put into the chat? Anybody? Okay, very good, and thank you for trying. So 117.0. The thing is that 0 is a significant figure, and also that was not a 0 here. So all you have to do is say 110. So let me just tidy that up. And we just simply say, I need 3 significant figures, so I just go for those. So I go for 117 grams. So you can write all those during the working, but your final answer must be to the correct number of significant figures and the unit. Any questions about why I dropped to 117? You can see that I have 3 significant figures. Nope. Okay, right. So what happens when I go from now one substance to another substance? So remember I said my formula, n is equal to small m over big M, has to all relate to one substance. So I'm going to go now to an example. Francis, that's a very good question. If your answer was where, say, the fourth significant figure was greater than 5 or higher, then yes, you would round up. So if you had an answer of 117.8, your final answer would be 118. If your answer was 117.5, your answer would be 118. We're not like supermarkets here. 5, you round up, you don't round down like in a supermarket. If you had 117.49, the answer would be 117, because you just look at the fourth significant figure, and if it's less than 5, you drop it. If it's 5 or more, you round up the third significant figure. Okay, right, so I am going to, sorry. Oh, okay, what's the difference between 1 decimal place and so on? Significant figures in decimal places are slightly different things, okay? When you're adding or subtracting, you go to decimal places, although you still got to be aware of significant figures to some extent. It really depends. But that's adding or subtracting. If I am multiplying or dividing, I don't even look at decimal places. I look at significant figures only. So for example, if I just sort of scribble on here, if I was adding 1.53276 and then I was adding 2.0, okay, I can't say that my answer is 3.53276 because I don't know what those figures could have been if I had measured those more accurately. So if you're adding, you just go by the least decimal place, okay? So I would not use those. My answer I would quote as 3.5 if I was adding. If I'm multiplying or dividing, I go by significant figures. So I have 3 significant figures here. Molar masses are normally always to 3 significant figures. And so your final answer will be to 3 significant figures. These 3 significant figures, 3 significant figures. So your final answer here would be to 3 significant figures. In fact, the way chemistry is set up, your answer should always be to 3 significant figures, really. pH is something slightly different, but unless you're doing scholarship, don't worry about that. Just put in 3 numbers or 2 decimal places for log values, because log values have different significant figures. They're just not, not every number is significant in a log figure. Okay, but right, so does that help in trying to work out the significant figures? Okay, right, so let's go here. So this is an example of mass, where this won't come up in the assessment task, but you will need to know this sort of thing for the exam standards and for level 3. So if you are going on to level 3, you need to know this sort of thing. So here I am going from one substance, well, let's start. I'm given a substance over here, and I have to work out the mass of another substance. So now remember what I said, your n is equal to small m over big M can only apply to a single substance. I can't have n or sort of m applying to Ki and then n applying to lead iodide. It's not going to work. You're going to get the wrong answer. So you need to be able to swap from one to the other. And the way that we do that is what we call the mole ratio. So if you think of mole is the way we count atoms, and the number or the ratio those atoms combine with or react with is what we call the mole ratio. So as an example, if I have an equation, then my mole ratio is given by the number in front. Now, chemists are lazy. So if you don't see a number, what do you think that number is going to be? What is that number that's missing in front of the lead nitrate? A 1. Okay. So whenever you don't see a number, it's lead nitrate. Sorry, it's a 1. So the mole ratio between potassium iodide and lead nitrate is 2 potassium iodides to 1 lead nitrate. If I was doing a mole ratio between potassium iodide and lead iodide, it's 2 potassium iodides to 1 lead iodide. If I was doing it from potassium iodide to potassium nitrate, it's 2 is to 2, and we always make down to the simplest ratio. So it's going to be 1 is to 1, because a ratio of 2 is to 2 is the same as 1 is to 1. Okay, so you always need to have a balanced equation if given a reaction. Now, again, in the assessment tasks and exams, they will give you a balanced equation. In the booklet, they may not always give you a balanced equation, so always check first that it's balanced. Because you never know in the exam whether they'll be mean one day, but they should always give you a balanced equation. Okay, you cannot do these calculations without doing a balanced equation of the reaction if given that. The other way you work out a ratio is, say, remember I said for your sodium sulfate, how much sodium is there in sodium sulfate in terms of mass? So let's just put that again. The mole ratio here, because what we're now comparing is the sodium with the sodium sulfate. So I am comparing sodium with sodium sulfate. So for every 1 sodium sulfate, how many sodium atoms or ions, how many sodium particles have I got in every 1 sodium sulfate? 2. Okay, you can see it by that little 2 over there. That's why that counting atoms that we did right in the beginning in the very first lesson is important. So you know how many particles, because sodium sulfate has got 2 sodium particles, 1 sulfur particle, and 4 oxygen particles, whether they're atoms or ions or whatever. Okay, so this ratio between sodium and sodium sulfate is 2 sodiums to 1 sulfate. So sometimes you have to look at the little numbers, okay, if they're asking you something within the formula, but if they're asking you in a reaction, you look at the big numbers in front. This is what we call the coefficients. So that's just a long word for the big number in the front of a balanced equation. So whenever you have something where you've got 2 different substances, you need to do 2 different calculations. So looking at this over here, let's do the first one. I mean, I've given you lots of examples. So I have got here calcium burns in oxygen to form calcium oxide according to this equation. So the ratio is, you can see I've got 2 is to 1 is to 2. Okay. So what do we know? We know, and this is always a useful tip, is to highlight what you're given. So we know that this is a mass of calcium. Okay, so we know the mass of calcium is 12.0 grams. We know we've got excess oxygen, and we have to work out the mass of oxygen that we're going to be using. Oh, there's a mistake here. Calculate the mass of oxygen used up. So if you're working through this booklet, whoops, I've gone down too far. Where did I go? Sorry, I've flipped down. Sorry about this. There. Sorry, this is a mistake. This shouldn't have been calcium oxide. I've asked for oxygen. So you are wanting to calculate MO2. So this should have been O2. O2. So the first thing you do is you look up the molar mass of calcium, and that should be, I'm pretty sure, 40.1. Tell me if I'm wrong, but I'm pretty sure it's 40.1. We'll just go with that figure. I'm just getting it out of my brain. Okay, I might have remembered it incorrectly. And we need to calculate the mass of oxygen because we don't know that. And we know the molar mass of oxygen. Now, if every oxygen is 16.0 and I have 2 of them, because remember, oxygen is a diatomic molecule. It can't exist as oxygen atoms. It exists as O2 molecules. And again, in assessment tasks, you're always given the formula as well, just in case you're going, oh, why should I know that oxygen is O2 and not O? You will be given these things. So it's 2 of them, so your answer is going to be 32.0. Notice that I am very, I keep my significant figures. I don't just say 32. So the first thing you need to do is work out the amount. We need to know the moles. Remember the mole ratio, so we need to know the amount. So the mole ratio is, I first must work out the amount of calcium. So I say N is equal to small m over big M. So it's going to be equal to 12.0 grams all over 40.1 grams per mole. And you get a final answer of 0.29925. You can just write the first 3 figures and ignore the rest, as long as you keep them all in your calculator. Okay. Just also, whenever you do a calculation, work out, is your answer sensible? Because it's so easy to make a mistake. So here, if you think about it, we are taking a smaller number and dividing it by a bigger number. So we expect an answer of less than 0. I mean, like 1 divided by 2 is a half. Okay, it's less, it's less than, it'll be 0.5. Okay. If you like less than 1, might be easy way of thinking of it. Whereas if you had said 41.1 divided by 12, because you got muddled up, then the number would have been a lot bigger. Now that we've got the amount of calcium, so that's the one we know, we need to work out what is the amount of oxygen. So my mole ratio is 2 calcium to 1 oxygen. So if I've got 2 is to 1 for oxygen, if calcium is 0.299, do I expect my amount in oxygen to be more than 0.299 or less than 0.299? I need 2 calciums for every 1 oxygen. So is 1 less than 2? Hopefully that's a straightforward enough question. Is 1 less than 2? Nobody want to have a go? Okay, 1 is less than 2. Yep. Okay, right. No, it's the other way around. You need twice the amount of calcium for every 1 oxygen. So 1 is less than 2, so you would expect your N for oxygen to be less than this value. So it's a half of 0.29925. Keep all those figures in your calculator. Okay, so I just go now divided by 2 equals 2, and now it's 0.1496. Again, you only have to write the first 3 numbers that's as during a calculation. You don't really have to worry about rounding as long as you keep all the figures in your calculator. And now we do the final one where it's the mass, where it's now the amount of oxygen multiplied by the molar mass of oxygen. So it's 0.149, etc. Okay, times the molar mass, which we got over here. That's grams per mole. And so now just multiply what's in my calculator with 32.0, and I should get 4.788, etc. So 4.7880, etc. So to improve this to an excellence level, I go, how many significant figures? These were all given to 3 significant figures. So I go to there, but now this is where that example came up. This figure here is bigger than 4. It's, or it's 5 and higher. So that means this 8 needs to go up. So my answer is going to be 4.79. And I have to have my units, and my units is mass. Okay, I've gone slightly longer than the half hour. I hope that was useful. So the mole ratio is important in order to be able to swap from one substance to the other. So if you are doing the titration standard, you're going to be titrating acid versus base. So you're swapping from an acid to a base, or the other way around, base to an acid. So you need to be able to do that conversion of one substance to another substance. Any questions? Okay, I'm going to stop recording here. Now, I know there was somebody new to Te Kura. So